What Happened to Mars? A planetary mystery presented by science at NASA. Billions of years ago, when the planets of our solar system were still young, Mars was a very different world. Liquid water flowed in long rivers that emptied into lakes and shallow seas. A thick atmosphere blanketed the planet and kept it warm. In this cozy environment, living microbes might have found a home, starting Mars down the path toward becoming a second life-filled planet next door to our own. But that's not how things turned out. Today, Mars is bitter cold and desiccated. The planet's thin, wispy atmosphere provides scant cover for a surface marked by dry riverbeds and empty lakes. If Martian microbes still exist, they're probably eking out a meager existence somewhere beneath the dusty Martian soil. What happened? This haunting question has long puzzled scientists. To find the answer, NASA is sending a new orbiter to Mars, called MAVEN. The goal of MAVEN is to figure out what processes were responsible for those changes in Martian climate, says Bruce Jokoski, principal investigator for MAVEN at the University of Colorado at Boulder. Scheduled for launch in November 2013 and due to arrive in September 2014, MAVEN is bristling with instruments to study Mars' upper atmosphere. That's where many researchers believe the answer lies. The only way Mars could have been wet and warm 4 billion years ago is if it also had a thick atmosphere. CO2 in the Martian atmosphere is a greenhouse gas, just as it is in our own atmosphere. A thick blanket of CO2 and other greenhouse gases would have provided the warmer temperatures and greater atmospheric pressure required to keep liquid water from freezing solid or boiling away. Somehow, Mars lost most of that blanket. One possibility is the solar wind. Unlike Earth, Mars is not protected by a global magnetic field. Instead, it has magnetic umbrellas scattered around the planet that shelter only part of the atmosphere. Erosion of exposed areas by solar wind might have slowly stripped the atmosphere away over billions of years. Recent measurements of isotopes in the Martian atmosphere by the Mars rover Curiosity support this idea. Light isotopes of hydrogen and argon are depleted compared to their heavier counterparts, suggesting that they have been lost to space. Scientists have also speculated that the planet's surface might have absorbed the CO2 and locked it up in minerals such as carbonate. However, while carbonates have been found on the surface, they aren't present in enough abundance to account for an early, thick atmosphere. MAVEN will be the first mission to Mars specifically designed to help scientists understand the ongoing escape of CO2 and other gases into space. The probe will orbit Mars for at least one Earth year. At the elliptical orbit's low point, MAVEN will be 125 kilometers above the surface. Its high point will take it more than 6,000 kilometers out into space. MAVEN's instruments will track ions and molecules in this broad cross-section of the Martian atmosphere, thoroughly documenting the flow of CO2 and other molecules into space for the first time. MAVEN's instruments also will measure the solar energetic inputs into the Martian upper atmosphere and the atmospheric response. This will allow us to determine the processes that are responsible for that loss to space. Once Jokoski and his colleagues know how quickly Mars is losing CO2 right now and what might be causing that loss, they can extrapolate backward in time to estimate the total amount lost during the last 4 billion years. MAVEN will determine if loss to space was the most important player in driving Martian climate change, Jokoski says. In the grand scheme of the solar system, Earth orbits alongside a world that began with as much promise for life as our own, yet turned out so differently. After all these years, MAVEN could write the final chapter in a haunting planetary mystery. For more clues to the mysteries of Mars, visit science.nasa.gov.